All right, let's suppose we have this question. So two aeroplanes leave from an airport at the same time. Airplane A flies on a bearing of 124 degrees at a speed of 450 kilometers per hour. Airplane B flies on a bearing of 214 degrees at a speed of 380 kilometers per hour. Find the distance and bearing of B from A after 1 hour. Okay, so what we have to do is set up a diagram to help look at this. But first thing we have to define are what are bearings. So this video is going to be talking about bearings. So bearings. So bearings are basically angles, but they're very specific, kind of finicky angles. So there are a couple of things to consider. So firstly, you have to start from north and head clockwise. So what that means is that it says airplane A flies on a bearing of 124 degrees. So let's say this is airplane A. You would draw a direct line up north. So just a straight line north. And then it's going 124 degrees clockwise, which would look something like this, which would mean that airplane A is heading in this direction. It's heading in this direction, 124 degrees. So this north serves as like a compass, and you go 124 degrees north, you can tell 124 degrees of a bearing, and you can tell it's going in the direction of southeast. And you can use a similar principle for airplane B. So you have airplane B, so this is its initial position maybe, and it's flying on a bearing of 214 degrees. So when you have a straight line going towards north, 214 degrees end up right about there. So airplane B, you can see, is heading southwest instead. It's going in this direction. So using this, we can actually construct an equation. So it says that airplane A flies on a bearing of 124 degrees at a speed. So they leave from the same airport. So it flies on a bearing of 124 degrees. So we're going to say this is the airport. And this is north. And then airplane A is going this way, 124 degrees. It's 124 degrees, whereas airplane B is going this way, which is 214 degrees. So B, A. So we can say that this distance over here is a 90-degree angle, actually, because 124 plus 90 gives you 214. So it's saying find the distance and bearing of B from A after 1 hour. So we're told that it's going at 450 kilometers per hour for airplane A, which means that it would have traveled 450 kilometers in this 1 hour. The same thing goes for airplane B. It's traveling 380 kilometers per hour, therefore it's 380 kilometers away from the airport. So now what we have to do is find this distance. And as we can see, we've just used bearings to illustrate this diagram, and we can see this is a right angle triangle. So the distance we can say, which we can call D, since D is the hypotenuse of this right angle triangle, let me just draw this out, this right angle triangle. So this is the triangle. We deduce that this angle is 90 degrees, and we have side lengths of 450 and 380. So D is the hypotenuse, therefore D is equal to the square root of 450 squared plus 380 squared. And we can actually put this into a calculator right now. So 450 squared plus 380 squared is 346,900. And then if you raise this to the power of half, you get D is equal to 589 kilometers approximately. But now comes the most interesting part. Now we can actually find the bearing. So what we're going to do is first identify what they're asking us. So they're saying bearing of B from A. So B from A, as it says, it's from A, which means we're going to be focusing on A itself, and going to try and find out how to get to B from A. So the first thing when doing a bearing is draw the north. So it's straight up towards north. We know this is A. Then it's going to go clockwise until you reach B. And in this case, this line is connected to B, so that's the bearing. We're going to refer to that as x degrees. However, to find out x, we're going to need to know what this angle over here, we're going to call this y, and this angle, which we're going to call z, is. And then we can subtract, so I'm going to write this down, 360 minus y minus z will give us x, which is what we want. So how do we find y and z? Well, y is simple enough. It's basically, given that we have, I'm just going to erase this here. So we've got two parallel lines. These two north lines are parallel, and they're connected by one straight line. So the angles in between these two angles over here are going to add up to 180. So 124 plus y has to equal 180. Therefore, y is equal to 56 degrees. So we know that y is 56, but we now need to find z. So z we can actually find using the sine rule because we have enough information. We have an inner angle that's opposite a side length. We know what d is at this point. And then we've got another side length and an unknown angle. So we can say that sine z over 380, which is the opposite side length, is equal to sine 90 over its opposite, which is d. And in this case, d is 589. So if we rearrange, we get sine z is equal to 380 sine 90 over 589. In this case, we know that sine 90 is 1, so it's just 380 over 589. Therefore, z is equal to the inverse of sine of 380 over 589. And if we put this into our calculator, we get z is equal to 40.2 degrees approximately. I'm just going to write the approximately sign. All right. So now we know what y and z are. We can say that x is equal to 360 minus 56 minus 40.2, which is equal to 263.8. Rounding it to the nearest number, we get 264 degrees. So therefore, the bearing of B from A is 264 degrees. Another thing to keep in mind is if the bearing is only 2 digits, you wouldn't write it as, let's say we had a bearing of 87 degrees. You would not write it as 87 degrees. You would write it as 087 degrees. You always have to have a 3-digit bearing. And in most cases, you have to write it as a whole number. In this case, you do definitely have to write it as a whole number. So just round it to whatever the nearest number is because they want 3 significant figures, or 3 digits rather. So I hope this video was helpful in understanding how we can use bearings and link it to real-world concepts. So it's just about decoding this word problem and applying it into a scenario we understand. We use the sine rule to ensure we're able to compute this because the sine rule is something we've covered, whereas bearings is a bit more unfamiliar. So just draw a diagram is my biggest advice, and you'll be able to work through this problem. Anyway, I hope this was helpful. And let me know in the comments if you need any help. But until then, bye for now.